The idea of metamodeling is to build a predictive model using the predictions or scores generated by another model. By adding the predictive scores generated by an initial modeling algorithm to an existing pool of predictor fields, a second algorithm can then exploit these scores to build a final, hopefully more accurate model. Let's have a look at how that works. So using the same example that we used earlier, we can build three separate models independent of one another. They're all attempting to predict the same outcome, of course, which is customer churn for a telecommunications company. And then we can just refresh our memory as to the level of accuracy of each model before we build a meta model, if you like. So let's look at the neural network first of all. So the neural network, as you may recall, had 1,191 misclassifications. It's the most accurate of them all, followed by the Chade model, which has just slightly more, 1,198 misclassifications. It's interesting to note here that the misclassifications in the test group are 483 false positives and 715 false negatives, if you like. And although when we check the C5 we have exactly the same level of inaccuracy, they're not exactly the same. It's not the same records that it's inaccurate about, if you like, because the false positive and false negative rates are slightly different. But it's still, of course, 1,198 misclassifications, if you like. So to demonstrate meta modeling, what we want to do is take two of the models, we're going to combine them together, and we're going to use their scores to help us build a third final model. So I'm going to take the two decision tree models here, just copy and paste them, and I'll just remove the links, and then I'll just chain them together here so I can connect them together. Connect them up to the partition node, of course, because we want to see how well it performs on the test group. And then we can take the neural network modeling node, so it's exactly the same settings that we used earlier. We can connect that up and ask it to build a new neural network model for us, but this time it will incorporate the predictions from the Chade model and from the C5 model. And if we then connect that up, you'll notice I've got a filter field here. That's simply filtering out the predictive fields that the Chade and C5 model produce. Otherwise the analysis output looks a bit confusing, so that simply gets rid of that and keeps just the neural network predictions. Now if we run that, we notice now that the level of inaccuracy, the number of misclassified cases, has gone down to 1,002. So there's nearly 200 cases more accurately classified by using this meta modeling technique.